Hello Chem 1A, this is Chapter 2, Lecture Video 2, and we're going to be talking about mass numbers and isotopes in this lecture video. So every atom of any element has a very specific number of protons. For instance, if we're talking about carbon, carbon is atomic number 6. All carbon atoms have 6 protons. And if that carbon atom is neutral, i.e. no charge, then it must also have 6 electrons. However, carbon atoms can have different numbers of neutrons. So, for instance, I can have 2 carbon atoms that are both neutral with 6 protons and 6 electrons, but with different numbers of neutrons present. The same element with different number of neutrons, or in other words, a different mass number, is known as an isotope. Because if you have different numbers of neutrons, then protons plus neutrons is your mass number, and your mass number will be different between the two atoms. These are called isotopes. So for instance, carbon actually has 3 major isotopes it has, and there's carbon 12. This 12 here that we see dashed is the mass number. So we know that we can then write its symbol as 12, 6, element C. That is one of the most common isotopes of carbon, and by far most carbon atoms are carbon 12. However, there are 2 other carbon atoms out there, and that's carbon 13 and carbon 14. Carbon 13 has a mass number of 13. Carbon 14 has a mass number of 14. And if we look at the subatomic particles here, carbon 12 has 6 protons, 6 neutrons, and 6 electrons when it's neutral. And carbon 13 has 6 protons still, 6 electrons still as it's neutral, but 7 neutrons. And carbon 14 has 8 neutrons. So those are the main distinctions. One of the things we can do now, from an elemental symbol, you should be able to determine the number of protons there are, the number of electrons there are, and the number of neutrons there are in that element, in that atom. Each of the so let's do that. All right, so we have an atomic symbol here. If we want to figure out protons, that's the easiest one for the first place because the atomic number is how many protons. So I know that this element has 19 protons because it's potassium. Neutrons, we have to determine from the mass number, right? So we know the mass number is protons plus neutrons, right? Our mass number is equal to 40. And that's equal to protons plus neutrons. And since I know my protons are 19, then I must have 21 neutrons. Electrons are a little bit tricky. We know from the symbol that there is a positive 1 charge on this potassium ion. This means that the number of electrons and protons are not equal in this case. I know that the electrons have to be 1 fewer than my number of protons because if I have an overall +1 charge, that means I have to have 1 more proton than electrons, making the number of electrons 18. We can do this again for another one. All right, so this is my favorite element on the periodic table because it's my initials. It's technetium, pretty cool element. It's the lightest weight radioactive element. The lightest element that has no stable isotopes, so it's all of them are radioactive. So we know, again, protons here are 43 because the atomic number is 43. We can get our neutrons here. Again, that would be 96 minus 43, which gives me 53 neutrons. And since it's neutral, we know that the electrons have to be equal to the number of protons, so 43. Okay, we'll do one more. We have Br 81. So again, we have protons are equal to 35 here because of the atomic number. And we know the neutrons got to be equal to the mass number minus the protons. So we know mass number is 81 minus 35 equals 46. And since it's neutral again, our electrons have to be equal to 35. All right, so let's move on. Some other questions that we can see on this topic is if we're comparing two elemental symbols or atomic symbols, which ones do they contain the same number of subatomic particles for, right? So in this case, we know for sure that they don't contain the same number of protons because they're different elements. And since they're both neutral, they don't contain the same number of electrons. This leaves neutrons. And if we look at the mass numbers and the number of neutrons, for potassium, it has 21 neutrons here because 40 minus 19 gives you 21. For Cl, it has 38 minus 17, also 21. So they both have the same number of neutrons. In the next element, we see, or the next setup, we see that they both have an atomic number of 19, which means both these potassium isotopes have the same number of protons. They have different mass numbers, so that means they don't have the same number of neutrons, but they also, since they're both neutral, have the same number of electrons. So in this scenario, we have both the same number of protons and electrons, and in both, they have 19 of protons and 19 electrons. The last setup here, we know we don't have the same number of protons. In this case, we also have 20 neutrons for this potassium, and we have 18 neutrons in the chlorine, so it's not neutrons either, and it's not protons. If anything's in common, then it has to be electrons, and if we look at this, it is in fact electrons. Since this guy has a -1 charge, that means it must have one more electron than it has protons, and since it has 17 protons, it must have 18 electrons. The same thing is true here. The potassium has to have one less electron than it has protons because of its positive charge, which means it has 18 electrons. In other words, these two things only have electrons in common. So let's talk about the periodic table a little bit. There are a number of parts of the periodic table that you need to be kind of well versed with. There are the metals, which is basically everything to the left of this green thing here. So everything that I've kind of outlined in black is a metal. And there are the nonmetals, which are everything that's not green over here, plus hydrogen. So these guys and hydrogen are our nonmetals. Then there are the metalloids or semimetals, which I've bracketed in red here. And that's what I would try to remember, because if you remember where the metalloids are, then anything to the left of the metalloids, again, exception being hydrogen, is going to be a metal, and everything to the right is going to be a nonmetal. There are also the halogens, and these are what we call family names. Columns are called families on the periodic table, or groups. And these are the halogens: fluorine, chlorine, bromine, iodine, and astatine. And you need to know that those elements are also known as the halogens. There are the noble gases: helium, neon, argon, krypton, xenon, and radon. And you should know that those elements belong to that group as well. There are the alkali metals, which is this column minus hydrogen, because hydrogen is not a metal. And you should know how to identify those on the periodic table as well. And finally, there are the alkaline earth metals, which is the last group that we're going to talk about, and they're in the second column of the periodic table. There's two other groups that are kind of known together, and that's the lanthanide and actinide series. They're not so much a group, but a series or a period, because they're a row. So the top row here is my lanthanides, and the bottom row here is my actinides. And you should be able to kind of know that as well. One question I could ask would be, which of the following elements is an alkali metal, or an alkali earth metal, or a halogen, or an actinide, or a lanthanide? And I could give you a multiple choice question where I have everything except, one of them being not that group. So again, periodic tables have to have funky names. We don't call columns on the periodic table a column. We call them either groups or families. And they're numbered in kind of weird ways. We go 1, 2, A, both A, then we skip this middle part, and that's 3, 4, 5, 6, 7, 8A. And then the middle group here are labeled with a B and numbered very oddly. I do not need you to know the column titles or numbering, but I do need you to know the group numbering, or I'm sorry, the period numbering. Rows on the periodic table are called periods, and we count top down up to 7. So the top row is row 1 or period 1, then 2, 3, 4, so on. Now there are some regions on the periodic table as well. You should be able to determine whether an element is a metal, non-metal, or metalloid. The block in the middle here is known as the transition metals, and they're going to be kind of playing a big role later on in the class. The light blue that you can see here is actually the main group metals. The green is the metalloids, the orangish color is the nonmetals. And you should be able to kind of determine whether an element falls into one of these 4 categories.